Here is an explanation for the answer to final exam, question number 23 in Electronics Demystified, 2nd edition. If you have the printed book, you'll find this question on page 421. A bipolar transistor can exhibit considerable dynamic current gain under one or more of the following conditions, and we're given 4 choices, or all of the above is choice E. Well, let's look at a grounded emitter circuit, or also known as a common emitter transistor circuit. If we want to get considerable dynamic current gain out of a transistor circuit, we have to talk about the behavior in the grounded emitter circuit, and that is a phenomenon called the beta of the transistor. The beta of the transistor in the grounded emitter configuration is the amount of change that occurs in the collector current. That would be this current going from the collector to the power supply, the amount of change in that current for a certain amount of change in the base current. The change in the base current is caused by the input signal. We bias the base in such a way that the transistor will conduct from the emitter through to the collector, even under no signal conditions. But when we change the instantaneous value of the input current, then we get a change in the output current at the collector. The beta is the ratio of the change in the output current to the change in the input current, and hopefully that will be greater than 1. If we want an amplification circuit here, we want that beta to be greater than 1. Well, as things turn out with any transistor, the beta that we can theoretically get, the maximum beta or the maximum dynamic current gain that we can get in this configuration, depends on the type of transistor manufacturer. But in general, no matter what kind of a transistor we use, the beta will always improve. The maximum beta that we can get will always improve as the frequency goes down. So the only choice that makes any sense here is choice A, below its alpha cutoff frequency. Now the alpha is a completely different specification in a different kind of a circuit, but in general, if we go far enough below the alpha cutoff frequency, we can get considerable dynamic current gain. So choice A works. Choices B, C, and D just don't work. They just don't make any sense. When the input signal is too weak to produce collector current during any part of the cycle, well, if that's the case, we're not going to get anything here, and the dynamic current gain is going to be 0. So that isn't going to work. That's choice B, so we can rule that out. Choice C, in a state of saturation. Well, again, if we saturate a transistor, we can't make the collector current change by changing the input, unless the input is just so large that it causes a slight change during part of the cycle. But we wouldn't want to operate a transistor in a state of saturation in order to try to get gain, so choice C is wrong. D, above its beta cutoff frequency. Well, the beta cutoff frequency, also called the gain bandwidth product, is the frequency at which the value of beta, that's the dynamic current gain in this circuit, declines all the way down to 1. So if we go above that, we're going to get less than unity gain. We're going to get a loss. So choice D doesn't work either. You can read about all of these specifications for transistors, alpha, beta, alpha cutoff, beta cutoff, from page 178 through page 180, and then the common emitter, common base, and common collector circuits are described up to about page 184. So Again, the correct choice here for this question is A.